spacewalk simulation. By reading all the instruction carefully, you are obliged to work on those rubrics or the project. Not following the instruction will result you in not earning the score you want on the assignment. The learning outcomes of this project is by completing this project, you will model and simulate random spacewalks based on different movement patterns. Group the astronaut movement data using data structure, for example, list. It should be list within a list, like a nested list, or the dictionaries. Again, if it's a dictionary, it could be like a nested dictionary. Visual the movement with Python's matplotlib. This is the new thing, very new thing, matplotlib. So it is Python library function we'll be using to visualize those movements. I'll show you how you can do that. Separate the data generation from visualization logic to structure the simulation properly. Use loops and function to reduce the redundant code and enhance the maintainability. Mission brief. In the context of Exodus, the humanity rebirth, what we're solving throughout the semester, humanity is in the midst of the greatest migration ever attempted, fleeing Earth, dying surface, and traveling towards the new Earth-like planet, Nova Gaia. On board the massive generation ships, astronauts, engineers, and colonists must conduct the spacewalks to maintain and repair the critical system, navigate the asteroid fields, and prepare for future operation on Nova Gaia. Brownian motion. How many of you have heard the Brownian motion? It's from the botany, right? Or chemistry. So no, actually it's from the chemistry, but he was a botanist. So discovered by botanist Robert Brown. He was a botanist, but he designed or found a motion, which is called like a Brownian motion. It refers to random erratic motion for particles suspended in a fluid. The phenomenon was later modeled mathematically and has widespread applications for physics to financial markets. A random walk is a mathematical model that describes such erratic movement where each step is determined randomly, often with equal probability. Random, but equal probability. This simulation, Pathfinder Tracker, would model the movement of astronauts during their spacewalks. These astronauts are essential to the survival of the colony. They maintain the ship's outer systems, set up communication arrays, and conduct the repairs. Spacewalks are perilous and unpredictable, so understanding and tracking their movements will be vital for both training and mission success. In this project, you will simulate the movement of 3 astronauts on a spacewalk, each with their own behavior pattern. The data will help monitor their action, predict their behavior, and ensure that the mission's objectives can be met despite the random and chaotic environment of deep space. So these are the mission brief. So what is the project description? As a part of the Exodus mission, you are tasked with simulating the spacewalk movements of 3 astronauts, Lance, Sophia, and Finn. And their movement patterns will mimic the unpredictable nature of their task as they navigate the ship's external systems or maneuver around asteroid during the critical repairs. Each astronaut has a distinct way of moving, and you must track their position throughout the spacewalk and visualize their pattern. For example, for the Lance, he moves randomly in any direction, up, down, left, right, with equal probability. His movement will be represented by blue circle on the plot. Whenever you are drawing a plot, it should be a blue circle for the Lance movement. Sophie prefers to move upward towards higher coordinates with a 50% chance of moving up and 16.67% of each of down, left, and right. That means going upward most of the time, and it is equally distributed to half of the movement to down, left, and right. So if you divide 3 by 50, it is like 16.67. That's why we're saying equally rest half. So for the first half, it is going upward. For the rest half, it is equally distributed to down, left, and right. She will be represented by the red squares. Last one is the fin moves only horizontally left and right, avoiding any vertical movement. His path will be visualized by green triangle. That means if we have an equal probability for the length, so if this is the starting point, it can go this direction, that direction, that direction, and that direction, like with equal probability. So for example, this is our time span 0, 0, 0. If you're saying it's like a 1 unit, and it's a 25% probability on each direction. It could be anywhere. So first we can assume this one. At time 0, it can be here. And again from here, it has 4 new probability. 1, 2, 3, and 4. If we're saying, well, no, it's not going the rightward, it goes to the upward, as it's like 25% probability. It can go anywhere. So the next move should be from here, 1, 2, 3, 4. It could be happen on left and downward as well. If it is a leftward, then the next move should start from here. If it is downward, it should start from here. Right? But we don't know where it can go. For example, it goes here for the first move and here for the second move. That means at step 2, it is here. But it's like a 25% and then 25% of 25% chance. Right? It could be 100%, that's because 25% is a percentage. Or it can go on the first move here and second move here. So it could be here. Or it can go first move here, second move here. First move here, second move back to again, the origin. So we can start from 0, 0. I'll show you those things later. What is the coordinate geometry? But this is like a lens spacewalk. Now, what is for the what's the second one? SOFI, right? For the SOFI, this is our 0, 0. It goes upward 50% of the time and 16.67 in those places. So mostly it can go upward as because it's 50% chance. We assume it goes to here, and from here it can go again those places. So since it is like a probability, I can assume like it can go here. And it could be go here. High chance is going upward, but I can say like here. So on the second move, it goes like she goes here. But we never know. Since I'm telling it's like 50% of the chance, if you simulate his walk for like 1,000 times, probably it is somewhere here in the upward direction. Maybe first chance half, second chance right, third chance down, fourth chance again up, fifth chance up. Since it's 50% chance going up, so probably it goes upward direction. For the third one, fin has a preference to go left and right, not going upward. Already he's in the up, so he's going left and right. So starting from here, he never goes to up and down. He goes either right or left. It is a high chance he stays at the same place. First move right, second move left, third move right, fourth move left. Till he's in the 0th position. He's lazy, right? He's going forward and backward, but he's moving. But there is a chance he can go all the way to forward, all the way to backward, but not upward and downward. So you need to simulate those 3 astronauts spacewalk using a graph. If you know the point, so what I can do here, for example, fin goes here first point, This is the first point. This is the second point. This is the third point, fourth point, fifth point, sixth point, 7 point, 8 point, 9 point. So what would be the graph? The graph should be like this. This is the graph for what is the color? It's the green triangle. There should be green triangle. So on your graph, it should be like that, green triangle. Now, if it is not the fin, like Sophie, she goes upward most of the time. And what is the symbol? Blue circle of the blue color. Starting from here, first move, second move, third move, fourth move, fifth move, sixth move, seventh move, eighth move. So what I can do, I can draw a line from here. So this is the path for Sophie. And for the lens, it could be anywhere. And what is the symbol? The Sophie was red square. I missed it here. Sophie was red square. I don't have, oh, I have red. It should be red square. Now, for the lens, he can go anywhere with equal probability. So, it's a blue circle. This is the 0, 0 point, starting point. So, equal probability can go anywhere. So, this is the line for lens spacewalk. So, you need to draw those things. But since it's the random, if you run your code second time, it will not be the same as the first one. But at least some pattern. For the fin, it should be a horizontal line, right? Every time it's a horizontal line. For the Sophie, it should be in the upward direction, mostly, since 50% chances are going to the upward. But for the lens, it is like totally random. It could be anything. All the way to up, all the way to down, somewhere in between this coordinate, that coordinate, or wherever in the space. Okay. So this is our task for the project. So what you need to do? What is our task? Model the spacewalk for each astronaut for 500 steps. Track their position after each step in a list or a dictionary. As I told you, starting from 0, 0. On the next move, it can go upward. Then you need to change the position. I'll show you how to change the position. Each astronaut starts the same position, 0, 0, the origin, and moves randomly according to their respective movement pattern. This is for the movement pattern. For the visualization movement, use the provided plot underscore pathfinder underscore walk function. I have given a function to you. You need to use the function. Like I'm giving you a library function. You need to use that library function to draw the plot. That function to visualize the paths for each astronaut. The simulation should produce randomly different outputs each time it runs, simulating real-world unpredictability. What you need to do, you need to produce 3 images, one for lens spacewalk, Sophie spacewalk, and Fin spacewalk. You need to store those images using .png. And each image will represent the paths taken by the astronaut during the simulated spacewalk. So since it's like a simulated, if you run next time, it will not be the same. It can be different. So here is a sample file with the function. So I have given the function here as well, but you can also download this file. In that particular file, you can find that function. So here's the function. Path, plot, pathfinder walk. You need to provide the astronaut information here. This will actually generate the image for you. Basically, you don't need to do anything, but at least you need to understand what's going on here. And what is the expecting? You can see here expected astronaut is a dictionary key, and the keys should be name, position, color, and the marker. The name should be either Lance, Finn, or Sophie. Position is a list of tuples. Color could be either blue, red, or green. For the marker, I told you 3 different types of marker: square, circle, and triangle. So square is for O. I'll show you how to find the markers code for that particular type. So this is particular triangle. This is circle, but I'll show you how you can find for the square. And if you provide the astronaut's information, it will definitely generate the astronaut name. What's the file name? The astronaut name _ spacewalk.png. That's what I'm expecting from you. Astronaut name _ spacewalk.png. So if you don't modify this code, typically this will generate an image for each astronaut. Now, you can also, for this particular case, I have used a dictionary. If you'd like to modify, it's like, well, I don't need to use a dictionary. Rather, I can use a list of lists, not list of dictionaries. In that particular case, you need to modify this function. That can be challenging. If you'd like to take the challenge, you're most welcome. Otherwise, you can use my library function. It's up to you. Okay. So these are the functions here again. The key program requirements and the rubrics are ensure each astronaut's movement is implemented as is described here. So Lance random movement all 4 direction. Sophie prefers upward, 50% chance, and equal chances for the rest of the other directions. Finn just move horizontally, left and right only, not up and down. Then ensure the output is different each time the simulation is run, simulating the randomness. So if your code is generating the same image every time, that means your code is not using the random behavior. So make sure you run your code multiple times so that you have different types of images, but similar type, not exact same. Like, for example, I told you about the fin. It should be a horizontal line, but maybe shorter range or longer range. For the lens, it should be in upward. It can be any direction. So definitely you will see random point, like last point for lens on every run. For the Sophie, it should be upward direction most of the time, but somewhere in between the upward direction, not the same place when you're like running your code every time. Use the appropriate data structure list, as I told you, nested list for the dictionary, nested dictionary to track astronaut movements. Use only necessary global variables and ensure astronaut initialization is correct. This time, you can use a global variable, but they are limited for only the astronaut initialization. Whenever you are initializing an astronaut, you can only use a global variable. But not necessarily you need to use a global variable. If you bypass it, it's totally fine. But as we are using plot pathfinder walk, probably writing the astronaut as a global can help. But if you just write this function within a function like an inner function, that can solve this problem. That means you don't have any global variable, but you are allowed in this particular project to some extent, not all of those. So necessary means like whenever you are initializing the astronaut. And those 3 are the common thing, not 3-2. Use the appropriate snake case or camel case for variable and function names. So snake case means like snake case and camel case in this project. Use loops and function to avoid repetitive code to manage the astronaut movement. Implement a main function with conditional execution. This is what you have done before. These are the example run. Upon running the simulation, you will generate images showing the paths of each astronaut spacewalk. Make sure you use the blue circle for Lance, red square for Sophie, green triangle for the Finn. And your Python code should be inside the pathfinder_tracker.py file. I already have given that file, excuse me, with the function. So you can just copy that function to your new file, or you can use that file from there. And as I told you, you can use this function, but you're not required to use it. So if you're not required, that means you need to modify this function based on the other specification. But right now it is expecting a nested dictionary. If you plan to use other data structure than the dictionary, you need to modify this function. And the image's name should be the astronaut name underscore spacewalk.png. Sophie, Finn, these are the three other things. Any question? Do you understand what you need to do? What do you need to do?
Make 3 charts.
Make what?
Make 3 charts for the randomized movement of the 3 different astronauts.
Okay. So randomize. How do you do these things?
Import random.
Import random. Great. Then randomize here is like with some probability. How do you do that?
Define probabilities.
What's that?
Define their each specific.
Yes, definitely define the probability. This is the first thing. The second thing is like how you can incorporate those probability to that function, or to what function you can use. Like random is a library. It has a lot of functions. What function you can use? This is the first thing. A second thing is easier, like you need to generate an image. I already have given the function. You can just use that function to generate the image. And make sure you run your code for 500 steps for each astronaut. Okay. So let me show you. So these are the rubric that I just have mentioned. What you need to do, simulate the random walk for several astronauts as described. Each time you run the simulation, it produces randomly different output images for each, not animal, it should be astronaut. So it was the previous project was random animal walk. So I haven't changed the astronaut. So astronaut is not an animal. So it should be astronaut and save it to a file. Use dictionaries or list to group the information, and you can use that dictionary or list as a global variable in that particular project. The only global code allowed is the information about each astronaut. I should change it to astronaut. Okay, and the main function global with the conditional the execution is done. You have done those things before. Variable names and code follows the snake case or camel case. So we already have done those things, but we don't know how we can simulate our random walk, how we can save those pattern in a file. But as I told you, if you use that function, it is easier for you. But I'll show you how you can use the randomization for any simulation. So for the randomization, you can use those two functions, dot choice or dot choices. This is definitely from the random library. You need to import the random. The choice and choices. So from the function definition or naming, you can see for the choice, it will return only one choice. For the choices, it will give you multiple choices, right? So depending on your implementation, you can use either of them, either choice or choices. Then plotting the walk, matplotlib. Last class, I talked to the other student about the matplotlib. It is basically, so have anyone heard the MATLAB? It's another programming language. Typically, electrically, the students are trying to use electrical, mechanical students are using MATLAB for their simulation in olden ages. But now Python supersedes those things. So since Python is superseding, but taking the MATLAB things, that's why it is taking the name as math from the MATLAB. Plot is for the plotting purposes, and library is our library function. So matplotlib is a library where we can plot our data similar to MATLAB. And you can store those information by saving those files using the matplotlib function. For grouping the information, you could use either dictionary or list, but those should be nested. Like dictionary within a dictionary, dictionary within a list, list within a list. But as I told you, the given function is based on nested dictionary. If you'd like to modify your data structure, you need to modify the function. Okay. Do we understand the project description? It's time to start working with your design. What's in the design part? Louder. Like processes. What I missed or what you missed before the processing. What needs to be done?
Read it.
Well, definitely read. So in between read and the process, what I missed? Inputs, yes, inputs and outputs. So for the outputs, there are like three outputs, three images. For the inputs, what are those three inputs? The astronauts' information, right? What are those informations? The behavior of their walk and the step. They can walk 500 steps and they're done. And what is their pattern? The random behavior. So for the lens, it has a different behavior. For the fin, it's moving forward and backward. For the SOFI, it's going upward mostly. So those are the inputs. And output are the image file. And now you can start working with the processes. What algorithm you can use, what process you can use. Does that make sense? Any question? Okay. One thing that you need to recapitulate is the coordinate geometry. Probably it's not a good thing. Like if you don't like math, then it's not a good thing. But if you like math, it's great. Typically, I don't like the coordinate geometry in my high school. This is like a basic, but when it goes to very deeper, like three-dimensional, well, I got lost. But it's a two-dimensional. It's okay. So if you see here, like two-dimensional coordinate geometry, which is called like Cartesian geometry or Cartesian system, this is like a 0, 0 point, like our origin. And this is forward direction and positive to the x-axis. So there are like two axes, x-axis and y-axis, right? This is x and this is y. This is x positive number. This is y positive number. Similarly, this is x negative number and this is y negative number. And this is 0, 0. X and y are 0, 0. Now, 0, 0 is the starting point, origin. If it goes to 1 forward, let me draw this thing. This is our 0, 0 point. This is our 0, 0. And this is like upward. Upward means like maybe 1 unit up. What would be the point for this one? 0, 1. That means it is going up to the y-axis, right? What is this point?
1, 1.
1, 1. That means it is going up to the x-axis, but not the y-axis. What is this point? 1, 2, going x-axis as it is, but y-axis 1 upward. So what you can do, you can just define this like this is 0, 0. Whenever this is an upward, it should be 0, 1, right? 1 level up to the y-axis. When it is downward, This is 0, -1. When it is rightward, then it is 1, 0. When it is leftward, this is -1, 0. So for example, this is like our point 3. It's not 3, 4. Maybe this is -1, 1, 2, 3. -1, 3. From this point, if I need to go downward, I can add this number -1, 3, then 0, -1. So it is like -1, 2. This is how we can add our Cartesian numbers, x and y values. So if you just define those 4 things at the very bottom and the very top, whenever it's upward, add this number, downward, add this number, rightward, add this number, leftward, add this number. Then at any place, any point, if you have a left from your choice can be anything from left, right, up, and down, right? Those are the 4 choices. From 4 choices, it can pick anyone. Like for example, up. If it picks up, then for the up, you can just add this number with whatever your value is. So what exactly you need to do is you need to create a list of tuples starting from 0, 0. Then get the random choice from your random function. Maybe it's a right. From the last value, add right. 1, 0 plus 0, 0. What is the value? 1, 0, right? And on the next run, it can be not left, maybe up. For the up, it is like 0, 1. So from 1, 0, you need to add 0, 1. So it is like 1, 1. And how many times you need to iterate it? 500 times. That's what you need to do. In other way, you can use the choices function, which will give you all 500 choices at the very first place. You have a list of choices. For the first, it is left, right, up, down, left, right to 500 times. Then you need to map with 0, 0 to generate the list. You need to use, well, it's a left. What is the value of left? -1, 0. Add with the previous value to generate the next one, so on and so forth. Does that make sense? So yeah, for this particular case, you need to know the coordinate geometry, at least for these 4 things: up, down, left, right. And I already told you about the matplotlib. You need to install that particular library on your local machine. Sometimes if you don't install those particular library, you have an error. So this is the instruction to install the matplotlib on your machine. Python mpip install u matplotlib. It will install to your local machine so that you don't have any issue. And here's some tutorials for matplotlib. This is for the Geek for Geeks one, and this is for the matplotlib web, like the official one. Sometimes the official one is not easy to understand, so that's why I'm giving you the Geek for Geek one. So, and definitely for the official one, you can always find the exact values. For example, like this is triangle and square, what they have used for the triangle and square. So this is for the triangle. Okay, this is for the triangle, and for the square, for R, I think BS is the square. Let me see. If you go to the plot function, scale, where's the so this is for the color. You can find the color tag, which color you'd like to use. So B for blue, not black. R for red, C for cyan, M for magenta, but we're not using magenta, we're using blue, green, and red. So BGR, RGB. And if you go back to the shape, there should be an option for the shape or in a different name. Yeah, draw shape like DS. The draw shape, set the draw style. Screen is not working. Well, that's why I told, like, sometimes it is harder for you to find those things from here. In that particular case, you can go to the Geek for Geek. This is the like the select different types of graphing: line graph, bar chart, histogram, scatter plot, pie chart. But in this particular case, we're using a line graph, like pointing those dots to create a line. What is the function name? So matplotlib. Point shape. Oh, it's a marker. So here's the marker. Dot for point, circle for O, triangle for like down triangle for V. So you can use either one. Up triangle or down triangle. What is for the square? Square for the S, the square. What is for the B? So they have used BS. So oh, it's a blue square. BS, I think. Yeah, you can find those information from here. Okay. Any question? Well, as I told you, you don't need to learn too much about the matplotlib, but if you're interested, you can go through those pages. Like if you need to modify those things, or if you'd like to understand what I have written for the project. Okay.